Okay, so what is architecture? All right, so architecture is how a program, is how a computer system is designed and what technology it is compatible with. Okay, so architecture is macam mana kita nak buat kita punya computer system tu. Okay, and then teknologi apa yang kita nak pakai. Okay, and then macam mana dia punya what we call here, how we going to access the program memory and data memory. So that is the architecture. Okay, so the attribute of a system are visible to a programmer, di mana setiap architecture akan visible, okay, akan dinampak oleh setiap programmer. Sebab programmer ni kena tahu, okay, dia, computer architecture untuk dia orang buat programming, especially for the assembly language. Okay, this attribute have a direct impact on logical execution of program seperti instruction set. Okay, so what are the instruction set that are available in a certain architecture? Okay, number of bit used for data representation. Adakah that computer system is like 8-bit, 16-bit, 32-bit, and lepas tu how the number is representation, sama ada dalam bentuk binary ke hexadecimal, and then I/O mechanism. Okay, so what are input output yang available? Okay, macam mana kita nak access to the input output and addressing techniques, which is how we're going to move a data from one location to another location. Okay, there are two types of computer architecture. Okay, kita ada dua jenis computer architecture. One is a von Neumann architecture, the other one is a Harvard architecture. Okay, for the von Neumann architecture, a computer architecture with a physical single storage and signal pathway for instruction data. Okay, maksudnya kat sini dia hanya ada satu je single storage. Okay, macam yang saya tunjukkan tadi, untuk Atmega32 kita ada 3 data storage. Okay, which is first is a program memory, di mana dekat situ kita simpan kita punya program. All the program will be stored inside of the program memory, and then we have the data memory, all the execution instruction. Okay, all the data after we did the execution instruction will be stored to our data memory, and then EEPROM. Okay, for the von Neumann architecture ada satu je single storage. Okay, and a signal pathway for instruction and data. So kat situlah tempat dia nak simpan program, and kat situlah juga dia nak simpan data. Dia pakai one signal pathway, dia hanya pakai satu je buses. Okay, while Harvard architecture, a computer architecture with a physically separate storage, okay, and signal pathway. Maksudnya kat sini program memory and data memory, okay, dia separate, dia asingkan, dia tak sekalikan dia. Okay, for instruction and data. Okay, so ingat lagi tak fetch and execute cycle? So this fetch and execute cycle will depending on the type of von Neumann architecture that you going akan apa ni, bergantung kepada computer architecture yang kamu akan guna, sama ada kamu guna von Neumann ke ataupun Harvard architecture. Okay, sebentar ya. Okay, so let's look at the von Neumann architecture. Okay, so this is a von Neumann architecture, as you can see here. Okay, this architecture has a single storage memory for storage data as well as program to be executed. Okay, kalau kamu tengok kat sini, dia punya program memory and data memory share the same buses. Okay, so kat sini, okay, so this is the buses, di mana these buses here used to to communicate between the CPU and the memories. Okay, so in this architecture, processor needs 2 clock cycle to complete an instruction. Okay, so maksudnya kat sini, in order to do the fetch and execute, dia memerlukan 2 clock cycles, in which first dia kena fetch dahulu, and then after that, that one is for the first cycle lah. And then for the second clock cycle, barulah dia execute. Okay, so the pipelining ataupun sometimes we call it multitasking, okay, is not possible with this architecture. Kenapa pipelining atau multitasking tak boleh? Sebabnya dia menggunakan bus yang sama. Contohlah kalau kita dah fetch data from code memory, okay, kita tak boleh execute data kepada data memory. Okay, sebab kita guna bus bus yang sama. Once you dah fetch kat sini, so kita kena habiskan dulu fetch, and then after that barulah kita execute and hantar data daripada CPU ke data memory. Okay, that is the meaning by the pipelining. Okay, in the first clock cycle, the processor get the information from a memory. Okay, so this is a fetch instruction. Okay, how to fetch instruction and decode it. So in the next clock cycle, the required data is taken from memory. For each instruction, this cycle repeats and hence need 2 cycles to complete an instruction. Okay, so this von Neumann architecture is relatively older architecture and was replaced by Harvard architecture. So nowadays, all the computer system are using the Harvard architecture. Kenapa Harvard architecture? Because we are going to use the pipelining, kita nak buat multitasking. Okay, next, this is the Harvard architecture. Okay, as you can see here, okay, you have a code memory, data memory, and this is your CPU. Okay, so this code memory has its own buses, and while data memory also have its own buses. So they are separate, okay, between code memory dengan data memory. Kenapa? Sebab dia tak share the same buses. So for this Harvard architecture, processor can complete an instruction in one cycle if appropriate pipelining strategies are implemented. Okay, kalau kita untuk this type of architecture, computer system architecture, kita boleh buat multitasking dengan pipelining. Okay, so what happened here is in the first stage of the pipelining, the instruction to be executed can be taken from program memory and at the same time, dia akan execute sebab dia boleh share the same, it have different buses. Okay, so most of the modern computing architecture are based on Harvard architecture, but the number of stages in the pipeline varies from system to system. Okay, so kebanyakan sekarang ni, komputer sekarang menggunakan Harvard architecture. So that one is a architecture. Okay, so now we're going to see what is organization. Okay, kita dah tengok dah architecture. Ada dua jenis architecture. One is von Neumann and the other one is Harvard architecture. Now we're going to see what the computer organization. Okay, so computer organization is typically refer to the operational units of the system together with the interconnection. Okay, so this is how the features are implemented in this organization. Okay, what the programmer can see is, contohlah kita boleh tengok macam manakah dia punya computer organization of the certain computer. Contoh berapa input output available. Okay, so what addresses for the certain input output? Okay, contohlah for the computer A. Okay, kamu ada dua komputer, komputer A and komputer B. Okay, so komputer A kamu ada 3 USB port, while computer B ada 1 USB port. Okay, that is the difference between the computer organization. Walaupun dia guna the same architecture, which is Harvard architecture. Komputer A mungkinlah dia ada DVD player, komputer B tak ada DVD player. So that is a computer organization. Okay, so it is a consist of hardware details that are transparent to the programmer. Okay, so many computer manufacturer offer a family of computer models. So kalau kamu tengok kamu ada Acer, kamu ada Asus, kamu ada lagi MSI. Okay, so that is a computer manufacturer. Okay, dia banyak model dikeluarkan, tapi dia guna architecture yang sama. All of these computer manufacturer using the same architecture, which is AVR architecture, but with different in organization. Okay, maksudnya the computer organization between one model to another model are different from one to another. Okay, and architecture may survive many years, but its organization change with the changing technology. Okay, so now we're going to see what the computer looks like in early 90s and sekarang ini. Okay, so kalau kamu tengok kat sini, okay, so this is a computer in early 90s, this is 2000 and this is 2010s. Okay, so this is kita focus on the desktop je lah. Okay, we're not looking at the laptop. Okay, we're focusing on the desktop. Okay, if you can see here, okay, what are the different that you can find out from this computer here? In terms of architecture, apa yang dia punya architecture? Architecture masih lagi pakai Harvard architecture. But in terms of organization, okay, the organization are different lah from 90s, 2000 and 2001 and 2010. Contoh lah saya bagi kat sini. Okay, kalau kamu okay, mungkin this monitor here quite similar to this one 2000, tapi early 90s dia hanya boleh display apa ni, black and white only. Okay, tapi yang ni dah ada colored. Okay, of course 2010 kamu dah ada LCD screen, okay, ataupun LED monitors. Okay, lepas tu kamu tengok kat sini. Yang ni guna untuk apa ni? Okay, so this is your floppy disk. Okay, yang ni yang besar punya, and this is the floppy disk yang kecil. But in 2000, okay, no longer use the floppy disk. Okay, sekarang dia dah pakai DVD. But in 2010, okay, DVD pun dah tak ada. Okay, sebabnya kita dah pakai thumb drive untuk transfer data. Okay, kat sini kamu kena pakai floppy disk. Kat sini kamu kena pakai 2000, kamu boleh burn dalam DVD. Tapi kat sini kamu dah boleh, kamu pakai thumb drive. Okay, so the organization of your computer is changing from time to time. Okay, kalau kamu tengok kat sini, keyboard, semuanya ada keyboard. But the difference is, this keyboard here use a serial keyboard connector. Okay, yang bulat tu kita sambung dekat komputer yang ada bulat, dia punya connector is bulat. Okay, that is a serial connector. But this one here, this keyboard here using a USB. Okay, USB connector, but this one is wireless by using the Bluetooth technologies. Okay, kamu tengok tak ada wire. Okay, sama juga lah dengan mouse. Sini guna serial mouse. This one use USB mouse and this one use the Bluetooth mouse. And kalau nak tengok dia punya hard disk, okay, this one kita pakai HD hard disk. Yang ni dah pakai SATA. So 2010 dah pakai SSD. Okay, sekarang dah pakai SSD. Okay. So that is how the computer organization change from time to time. Okay, ada tak? Okay, for this slide here, I think you can read it by your own. Okay, now we're going to see the AVR. Okay, we're going to look at AVR. Okay, so this is the historical part lah. Okay, so designed by this person here. Okay, of Eagle-Bogen and Wegerwollen in Norway. Okay, and then it developed by the Atmel in 1996. Okay, so Atmel ni actually is a company lah. Okay, there are many kind of AVR microcontroller with a different properties. Okay, ada banyak jenis AVR microcontroller, except for AVR32. Okay, which is 32-bit microcontroller. All AVR adalah 8-bit microprocessor. Okay, so the size of the data bus untuk semua AVR microcontroller ada 8 bit kecuali AVR 32. Maksudnya kat sini, the CPU can work only 8 bit of data at one time. Kamu boleh transfer data 8 bit pada satu-satu masa. Ataupun kamu boleh proses data 8 bit pada satu-satu masa. Kenapa? Dia punya data bus is 8 bit. Okay, so data larger than 8 bit has to be broken into 8 bit pieces to be processed by CPU. Contoh kalau kamu ada 16 bit data, so kamu kena kecilkanlah 16 bit data tu kepada 8 bit by 8 bit. So kamu ada 2 8 bit data. Kalau kamu ada 32, so kamu ada 4 8-bit data. Okay, so the AVR is a modified hybrid architecture machine where program and data is stored in separate physical memory system that appear in different address spaces. Okay, so AVR adalah modified hybrid architecture di mana dia punya program memory and data memory are separated from one to another. Okay, so let's look at the AVR Family Overview. Okay, untuk AVR kita ada 4 jenis groups ataupun family. Okay, the first one we call it as a classic AVR. Okay, every time you see the 8090S, okay, followed by SSS ni dia punya model number lah. Okay, every time you see this 8090S, so you know that this belong to classic AVR. Okay. So this is the original AVR chip. Ada 3 model of classic AVR, okay, which is 2313, 2323, and 4433. Okay, so this is the size of ROM, RAM, EEPROM, and berapa bilangan input output. At the same time, sama ada dia boleh buat analog to digital converter ataupun tidak. Okay, and then bilangan timers. Okay, this timer is important lah kalau kamu nak generate a delay. Okay, so this is for the classic AVR. And then we have a mega AVR, okay, called as an Atmega XXXS. Okay, so in this class here, we are going to learn about the Atmega. Okay, so these are powerful microcontroller with more than 120 instruction. Okay, dia ada banyak instruction yang kamu kena belajar, which is more than 120. Okay, so in this class here, we will learn about this instruction here. Okay, how to write the Atmega programming. Okay, so it has a lot of different capabilities which can be used in different design. Okay, so ada banyak model dia, Atmega 8, Atmega 16, 32, 64, 12, 80. Okay, so in this class we are going to focus on this lah, Atmega32, di mana size ROM dia adalah 32 KB, RAM 2 KB, EEPROM 1 KB, input output, ada banyak input output, 32 input output port. Okay, boleh buat analog to digital converter, which is 8 bit, 3 timers, dan this is the pin number and packages. Okay, and then we have a tiny AVR. Okay, so every time you see the tiny, it belong the tiny AVR. So this one has less instruction and smaller package compared to mega family. Can design system with low cost and power consumption using tiny AVR. Dia sama macam ni lah kalau kamu pernah dengar Arduino. Arduino dia ada Arduino Mega and Arduino Uno. Okay, so Uno ni adalah lebih kurang macam tiny AVR lah. Kalau Mega tu belong to Mega AVR. Okay, so this is the part number. Okay, and size of ROM. berapakah bilangan input output. You see here, okay, since this is a tiny, nampak dia punya bilangan input output paling banyak pun 12. Yang tadi mega 23 paling sikit, paling banyak 86 input output. So kamu boleh connect 86 sensors to this IC. Okay, boleh juga buat ADC and timers. Tapi yang ADC ni hanya 4 bit ADC and this one is 8 bit. Okay, last but not least is a special purpose AVR. Okay, so the ICs of this group can be considered as a subset of other group, but their special capabilities are made for designing a specific application such as USB controller. Okay, contohlah kalau kamu nak guna USB controller, you're going to need to use this special purpose AVR lah. Okay, kalau kamu nak guna LCD, okay, kamu kena guna this special purpose AVR. Nak guna internet ataupun nak buat Bluetooth, nak sambung kepada Bluetooth modul, kena pakai this special purpose AVR. So this is the part numbers. This is the size of ROM memory, ROM, RAM, and EEPROM. Berapakah bilangan input output port and the special abilities. Okay, so kamu kena fokus on the special abilities lah. Okay, untuk LCD kena pakai Atmega169. Kalau kamu nak pakai USB, you need to use the 1890OU SB1287. Okay, so how to get familiar with AVR part number? So AT dekat sini stand for Atmel. Okay, the company that manufacture that chip. Okay, mega followed by the family, sama ada mega, tiny ataupun classic, and kat belakang ni dia punya size of ROM. Okay, so this is 1 to 8K, this is 4K, and this is 4K. But no need to remember this one lah. Okay, so dia takkan tanya. So we only focus on Atmega32. Okay, ada soalan tak untuk setakat sekarang sebelum kita fokus on Atmega32? Okay, sekarang ni kita nak tengok kita punya Atmega32, nak tengok dia punya pin out, berapakah dia punya input output, kat mana input output port dia dan sebagainya. Any question up until here? Ada soalan tak? Anyone?
Ada doktor.
Okay, tak ada. Okay, so we go to the Atmega32 pin out. Okay, so this is Atmega32. Dia ada 40 pin. Okay, yang ni dalam bentuk DIP lah, Deep Inline package, and this dalam bentuk socket. Okay, so selalunya kita akan tengok yang ni lah. Okay, kita akan refer to this package, DIP package. Okay, kalau kamu tengok sini, dia ada 40 pin, started from pin number 1 until pin number 40. Okay, previously kita tahu Atmega32 dia ada a total number of 32 input output port. Okay, dia ada 32 input output port. Okay, so kalau kamu tengok kat sini, kamu boleh daripada 32 tu, kamu boleh bahagikan dia kepada 4 port. Okay, which is port A, 8 daripadanya adalah dipanggil port A. Another 8 called as a port B. 8 lagi called a port C, and the last 8 lagi ada port D. So total number of input output yang kamu boleh guna adalah port D, 8 port D, and 8 lagi sebab kita ada total number of 40. Okay, ada 40 pin kat sini. So the remaining 8 untuk apa? Okay, so the remaining is for the reset. Okay, so this one here, you need to connect to your set. Okay, restart the execution of program. And then we have the VCC. Okay, so dekat pin 10 ni, make sure you connect to VCC, okay, with a 5 volt. Jangan lebih, jangan kurang. Kalau lebih terbakar, kalau kurang dia tak menyala. Okay, dia tak gerak, not working. And then we have a external. Okay, ada dua external, external 1, external 2. So this pin are used to connect external crystal for clock source. Okay, so this is how you're going to increase the speed lah. Okay, if you're going to increase the speed, so kamu pakai sambungkan kepada kamu punya external crystal untuk increase the speed of this chip here. Okay, and then we have the ARF. Okay, so reference motif for ADC. Okay, Atmega32 kita ada 8 kita boleh buat ADC, 8 bit ADC, di mana ADC ni kalau kamu tengok ada special function. Instead of port A ni, selain dia boleh jadikan input output, dia juga boleh buat analog to digital converter kat sini. Nampak ni, this is a special function. Okay, dalam ni, dalam kurungan ni, this is a special function for each of this port. Okay, so and then we have the AVCC. Okay, supply voltage for ADC and port A. Okay, you're going to connect to VCC by default pin 30 kita sambung kepada pin 10 sambung kepada VCC. And we have ground. Okay, dekat pin 11 dengan pin 31. Okay, so this is the Atmega32 Pin Out. Okay, kena tahulah ada 32 input output. Okay, which is boleh digrupkan kepada port A, port B, port C and port D. Okay, so the number of port in the AVR family on the number of pin on the okay, untuk 8 pin AVR has port B only. 64 pin version has port A through F. Kalau AVR tu ada 100 pin, so dia akan ada port A through L. But for Atmega32 kita ada 40 pin out, so kita akan ada 4 port, which is port A, port B, port C and port D. Setiap port ni adalah 8 pin. Okay, so 8 darab 4 kamu ada total of 32 input output port. Okay, so in order to use this port A, port B, port C and port D, sama ada nak jadikan dia input ataupun output, you must program. Kena buat programming dulu sebelum we can use port. So, kita kenalah tahu, okay, register yang untuk input. So each port has 3 I/O register associated with it. Okay, dia akan ada 3 register. Setiap port ni akan ada 3 register. Okay, one is called port X. Okay, ada 3 register yang terlibat. Saya punya pen ni. Okay, kamu akan ada port X. Okay, so this is the first register. Second register is DDRX. And third register is pin X. Okay, this X ni kat kita boleh ganti dengan A ni lah. Kalau kamu nak pakai port A, dia akan ada port A, DDRA, pin A. Kalau port B is port B, DDRP, pin B. Untuk port C, X ni kamu boleh ganti dengan port C, DDRC and pin C. Okay, and the function of each of this register here, okay, dia punya apa dia buat untuk ini. Kenapa kita kena tahu register ni, 3 register ni? Okay, first kita tengok ke DDR. Okay, this DDR called as data direction register. Okay, so data direction register. Okay, digunakan untuk menentukan sama ada we going to make this port A as an input or output port. Okay, determine either we are going to make it as an input ataupun output. Kat sinilah yang kita kena program nanti dekat DDR ni. Kalau kamu program dia sebagai input, okay, so the next is kalau kita program DDR kita sebagai input, so port A, contohlah port A dah jadi sebagai input port. So what happen here? Anything yang kita baca daripada switches, okay, input ni contohlah switch ke, kita nak sambung kepada switch, okay, kita nak sambung kepada apa lagi? button ke, okay. So every time kita press the switch akan disimpan ke dalam pin X, okay, akan disimpan ke dalam pin, okay. So kenapa? Sebab this one here is a data register for in or receive data, okay. So this is a read only, okay. Every time you make it as an input, so setiap kali kamu press saja your punya switch, this data from this switch akan disimpan dalam pin X. Okay, kalau kamu jadikan dia sebagai output, every time you going to send out the data from CPU to your output, so kita akan guna port X register. So this is the 3 I/O register that you need to know, yang kamu kena tahu, perlu ambil tahu. Okay, ada soalan tak sampai sini? Okay, kalau tak ada, okay, yang ni dia punya summarize tadi lah. Okay, so contohlah. Sebentar ya, sekejap ya, saya ambil 2 minit sekejap, masa 2 minit.
Boleh.
Boleh ya? Alright. Ini tadi. Okay, so sekarang ni, macam saya katakan tadi, okay, kamu ada DDR-X, okay, nak jadikan dia output, okay, kita kena letak 1, nak jadikan dia input, kita kena letak 0. Maksudnya, okay, tadi kita ada kita punya register, okay, yang ni, okay, contohlah dia is a port A. Okay, saya nak jadikan port A saya sebagai input port. Okay, so what happen here is I need to put 0 dekat saya punya DDRA. Okay, so this is my DDRA. Ini saya punya DDRA. So saya kena letak 0, 0, 0, 0, 0, 0, 0, 0. So sekarang ni bila saya letak macam ni 0, 0, 0, 0, 0, 0, 0, so automatically port A saya telah jadi input port. Okay, kalau saya nak jadikan port A saya sebagai output, so apa yang saya kena buat? Kalau port A sebagai output, so saya kena letak 1. I need to put 1. Okay, so saya kena letak 1. Tak nampak Okay, 1, 1, 1, 1, 1, 1, 1, 1 dekat saya punya DDRA. So automatic saya punya DDR port A akan jadi output. So the question here is macam mana kita nak letak value 0 ataupun value 1 ke dalam kita punya DDRA, sebab DDRA ni akan tentukan sama ada kita jadikan dia sebagai input port or output port. So how to do that? Okay, to do that, okay, so we need to do some programming. Okay, so kita kena buatlah programming. Okay, contoh kat sini, make port B as a output. Okay, kita nak jadikan port B sama dengan output port. So how to do that? Okay, untuk jadikan port B sebagai output port, so DDRB kita kena hantar 0 ke 1 output port. Okay, kamu kena letak 1. Okay, since kita punya port B ni ada berapa bit? Port B kita ada 8 bit. So that's why kita kena hantar this value here. 1111. Okay, which is kita kena letak 11111111 dekat kita punya DDRB. Okay, so macam mana nak buat program? Okay, so to do the program, okay, so inilah dia punya program dia. Mula-mula, okay, so kamu kena ingat dua lines ni dulu. Okay, load I R16, okay, 0B kita pakai binary number. Kalau kamu tengok 0B ni maksudnya dia is a binary number. 11111111. Kenapa ada 8? 1 ni sebab kita ada 8 bit tadi, betul tak? Kat atas ni. Okay, if you can see here, we have a 8 bit. Setiap port ada 8 bit. So that's why we need to send out 81 kepada R16. So what happen after you execute this line here? So R16 akan ada value ni. Ataupun, okay, sometimes tak nak guna binary number. Kamu nak guna hexadecimal number. Boleh. So LDI R16 0x. So sekarang ni value apa yang kita nak hantar? Okay, so this is binary number. Okay, binary nak tukar jadi hexa. Macam mana nak buat? Tekan calculator ataupun you can simply change by using the 8421 method. 8421 method. Ingat lagi tak? 8421. Okay, since this is 1111, so 8 tambah 4, 12, tambah 2, 14, tambah 1, 15. So 15 tukar ke dalam hexa, kamu akan dapat F. Yang ni pun 15 tukar ke dalam hexa, kamu dapat F. Yang ni dalam bentuk, okay, yang ni binary. Okay, so this one in hexadecimal. Tak nak hantar dalam hexadecimal, nak hantar dalam apa ni, decimal number. Boleh. Pakailah load I R16, tukarkan FF ke dalam decimal number. So kamu akan dapat 255. So 33 ni, okay, so 33 yang ni sebenarnya buat benda yang sama, which is kita nak hantar value yang ini ke dalam R16. Okay, so dia equal. Kamu boleh pakai sama ada pakai yang ni ke, nak pakai yang ni ataupun nak pakai yang ni. Okay, once value ni kita dah letak dalam R16, next barulah kita hantar value ni kepada kita punya DDRB. So macam mana nak hantar? Pakailah instruction out DDRB. Sebab ni kita nak hantar ke port B kan. Kita nak jadikan port B sebagai output. So DDRB. Okay, value tu, value berapa? Value daripada R16. Sebab tadi kita dah simpan dah value ni ke dalam R16. Kita dah load dah value ni ke dalam R16. So daripada that R16 kita masukkan ke dalam DDRB. So automatic after you execute this line here, what happen is port B become output port. Okay. Any question? Ada soalan tak sampai sini? This is how you going to make your input output your port as a input as a output port. Ada soalan tak untuk output port? Okay, kalau tak ada soalan, okay, now we going to make our port as a input port. Okay, so sekarang kita nak jadikan, let's say lah, make a port B. Okay, dia tukar ni, bukan output, input ya. Okay, how to make a port as an input? So nak jadikan dia sebagai input, kita kena letak kosong. Okay, jadi letak kosong untuk jadikan dia sebagai input. Okay, here letak kosong jadi input. letak satu jadi output dekat kita punya DDR-B. So sekarang ni kita nak contoh example to make port B. Okey, tak nak port B lah, kita nak buat port A. Okey, so port A sama dengan input port. So how to do that? Okey, so DDR-A kenalah kita letak 0 ke 1. Kosong. Okay, put 0 to your DDR-A. So how to do that? By doing the programming. Okay, so this is the programming yang kita kena buat. Okay, mula-mula hantar dulu value kosong ke dalam kita punya register. So R ni adalah kita punya register. Kita ada total of 32 register starting with R0 sampai R31. Okey, kita boleh pakai mana-mana R. Untuk yang I ni, immediate value, okey, kamu hanya boleh pakai daripada R16 sampai R31. Kalau kamu letak kat sini R0, salah, syntax error. Tak boleh. Dia kena pakai daripada R16 sampai R31. Okey, contoh untuk port A, saya pakai load I R20 misalnya. Okey, saya nak letak kosong ni tadi. Okey, masukkan 0 B 0 0 0 0 0 0 0 0 0. Okey, sebab kita ada 8 bit. Okey, masukkan this number to R20. Okay, and then out DDR-A. Kenapa nak DDR-A? Sebab kita nak jadikan input port A sebagai input. Okay, out DDR-A value daripada R20. So tadi kat sini R20 sebenarnya sama dengan 0. Okay, then after you execute this line here, what happen is port A sama dengan input port. Okay, ada soalan tak sampai sini? Any question up until here? Okay, if no question, then we move to the next slide. Okay, so define what happened. Yes, saya.
Nak tanya sikit, kalau macam yang tadi tu kita buat port A tu jadi input kan? Let's say kalau kita jadikan port A jadi output pula, jadi macam mana?
Port A nak jadikan output?
Yep.
Okay, so kalau nak port A nak jadikan dia output, apa yang value yang kita kena hantar dekat DDR-A? Kena hantar satu lah kan? Okay, so what happen here? Yang kat sini, 00 ni kamu gantikanlah dengan 1111 1111. So automatic port A jadi output port. Okay, boleh Nazra?
Okay, terima kasih.
Okay, sama. Okay, so let's look at this another example. Okay, define what happened to the pin when these numbers here, okay, kamu ada number ni, is write to your DDR-A. Okay, kamu ada nombor ni, okay, so this is your DDR-A. Kamu nak hantar value ni ke DDR-A. Okay, kita tengok line by line ya. First, load I R20 OX75. So R20 sekarang ni akan ada nombor 75. Okay, dalam hexa ya, sebab 0x. And then load I R70 OX0F. So R17 ada 0F. Out DDR-A R20. Okay, so hantarkan value daripada R20, okay, which is 75 ke DDR-A. Okay, mula-mula apa yang kita nak buat sekarang ni? Okay, 75. Okay, kamu ada 75 letak dalam R20. 75 ni kamu tukarkan dia ke dalam binary dahulu. Okay, by using the 8421 method lah. 8421, 8421. Okay, 7. Macam mana nak jadikan dia 7? Okay, 4 tambah 2, tambah 1 sama dengan 7. Yang ni kita letak kosong. Okay, what about 5? 4 tambah dengan 1. Yang lain kita letak kosong. So this is the binary representation for 75. Betul tak? Nampak ni? 0111 0101 which is samalah. Okay, so this number here kamu nak letak dalam DDRA untuk line yang ni. Okay, so DDRA sekarang ni dia akan ada nombor yang ni 0111. Okay, 0101. Alright, so this is your DDRA. Saya buat dalam kotak lah bagi senang nampak. Okay, so this is DDRA. Dan kamu ada port A, and then this is pin A. Kita letak dalam kotak. Okay, and then this is the kaki lah. Okay, the kaki. Okay, so this is PA0. This is a PA1 sampailah PA7. 4, 3, 2, 1. Okay, so this is the kaki. Okay, by referring to this one. Yang ni. Yang ni saya refer to gambar rajah ini. So this is the kaki. Okay, so sekarang ni value yang ni kamu hantar ke DDRA. So what happen here? Apa yang berlaku? Siapa nak tolong? PA7. PA7 ni sekarang ni jadi apa? Sebab kamu hantar kosong ni ke PA7. So what happen? PA7 akan jadi input ke output? Anyone?
Input.
Okay, dia akan jadi input. Okay, so data akan masuk. PA6 hantar 1. Yang ni output. Yang ni pun 1. So 5 ni pun output. This one is output. Yang ni input, output, input, output. Okay, so yang ni keluar, masuk, keluar, masuk, keluar. Okay, sebab according to this value here. Okay, sebab macam saya kata tadi, kamu punya port tak semestinya kamu jadikan dia semuanya sebagai input, tak semestinya kamu jadikan dia semuanya sebagai output. You can make them as a combination of input, output at the same time. Okay, so in this example here, so kita ada combination of input dan output pada satu masa yang sama. Okay, so sekarang ni, okay, nampak yang ni? Kita nak tengok, kita dah siap kat sini. Okay, kita dah jadikan certain port A sebagai input and another certain of the bit of the port A sebagai output. Okay, so now at this line here, out port A R17. So kita nak hantar value daripada R17, which is yang ni, value yang ni ke port A. Okay, so this is your port A. Okay, value yang kita nak hantar ialah berapa tadi? Yang ni, 0F. 0F is 0, 0, 0, 0. F is 1, 1, 1, 1. Okay, so sekarang kita nak figure out what are the number that will come out from your CPU to your kaki kat sini. Okay, kaki micropin. Alright. So sekarang ni, kosong ni, boleh keluar tak? Yang ni, dekat PA7. Boleh tak dia keluar ke sini? Tak boleh. Kenapa tak boleh? Sebab yang ni input. So value yang ni tak boleh pergi ke sini. What about this kosong? Boleh tak dia kamu hantar ke sini? Boleh, sebab dia adalah output. Kosong yang ni? Boleh. sebab dia output. Yang ini boleh sebab dia output. What about this one? Nombor 1. Boleh tak hantar? Tak boleh sebab yang ini input. So, tak boleh hantar. What about this one? 1 yang ni, boleh tak kita hantar dia daripada CPU keluar? Boleh sebab yang ni adalah output. So, ini dapat 1. Value yang ni, tak boleh sebab dia input. And value yang ni, boleh dihantar keluar sebab yang ni adalah output. So, by default, apa yang kita tak boleh hantar, kita letak kosong lah. Okay. So, sekarang ni, kalau kamu tengok, kamu nak hantar 0F. Okay, daripada CPU yang kamu nak hantar 0F. Tapi yang diterima di kaki ni adalah 05. Kenapa? Sebabnya ada serta-serta port ni kamu jadikan itu sebagai input port. So, dia tak boleh hantar keluar value yang ni ke sini. Hanya yang output je boleh hantar keluar, mana yang input tak boleh hantar keluar. Okay, that is the explanation lah kalau kalau kamu buat combination of input output port pada satu masa. Okay, contohlah. So, sekarang ni kamu nak line yang ni. In R18 pin A. Maksudnya kat sini kita nak baca value yang kita terima daripada pin A. Okay, and then kita nak letak dalam R18. Okay, let's input at pin A adalah 111. Maksudnya kat sini dia bagi tahu, okay, let's input dekat sini, dekat kaki ni adalah 1111111. Okay, apakah value yang akan masuk ke dalam kita punya pin A? Yang ni, boleh masuk tak ke dalam pin A? Boleh, sebabnya dia input. So, boleh hantar. Yang ni boleh hantar masuk tak ke dalam PA6? Tak boleh hantar. Tak boleh masuk. Kenapa? Yang ni output. So, dia kosong. Okey, mana yang tak boleh masuk? Kita letak kosong. Yang ni boleh masuk tak? Tak boleh juga. Sebab yang ni output. Yang ni pun sama. Kamu nak baca 1. Tapi sebab yang ni output, so dia tak boleh masuk ke pin A. What about this one? Okey, yang ni boleh sebab nombor 3 ni kita jadikan dia sebagai input. Yang ni tak boleh, kosong. Yang ni boleh, okey, yang ni boleh, so 1, and yang ni tak boleh, kosong. Okey, so kalau kamu tengok kat sini, by right, kamu nak hantar value FF. Kamu nak baca value FF ke CPU. Tapi disebabkan setting pada DDRA ni, CPU hanya terima value 8A. Nak hantar FF tapi dapat 8A. So 8A ni nanti akan disimpan dalam R18. So yang ni lah value ke R18. Okey. Faham tak? Any question? Ada soalan tak? Okey, kalau tak ada soalan, jom kita akan masuk pula. Okey, this is for the DDRS lah. Tadi kita ada 3 register yang terlibat untuk input output. 1 DDR, 1 lagi pin. Okey, so sekarang kita tengok pin register. Okey, so this pin register is used to read data at the AVR pin. Okey, nak baca data daripada AVR pin. Okey, daripada kaki ni kita nak baca masuk ke dalam CPU. Okay, in which to bring the data into CPU from pin, we read the content of the pin X register. Okay, so everything yang kamu masukkan daripada sini, selalunya kalau kita jadikan dia input, kita akan sambung kepada switch lah. Kalau kita jadikan dia output, kita akan sambung kepada LEDs. So every time you press the switches here, akan masuk ke dalam pin A register. Okay, contohlah, this is the value. Dekat kaki sini. Okey, dekat kau punya pin kat sini, kamu hantar kat value ni. Disebabkan okey, kamu punya disebabkan port X ni kamu jadikan dia sebagai all this input, so all this value akan masuk ke dalam pin X register. Whatever value daripada kaki ni akan masuk ke dalam pin X register. Okay, so this is for the pin X register lah. While for the port X register, okay, so port X register is used to send the data out to the AVR pin. Maksudnya kamu nak hantar daripada CPU, nak hantar data ke luar ataupun output. Yang ni tadi, data daripada input, okay, nak bawa masuk ke dalam CPU. Okay, so however, port X register also can be demonstrated for inputting data by putting one to activate the pull-up resistor. Okay, yang ni kita akan tengok nantilah apa fungsi pull-up resistor. Contoh kat sini. Okay, this is the value yang kamu nak hantar daripada CPU. Okay, so dia akan disimpan dalam port X register. Since your port X sekarang ni kalau kamu tengok, kamu jadikan dia semua sebagai output. So all this value kat sini akan boleh dihantar keluar. Dia tak sama dengan yang ni tadi. Yang ni kan kita ada combination input and output at the same time. So that's why a certain value from the CPU tak boleh dihantar keluar and a certain value from the pin X tak boleh masuk ke dalam CPU. Okay, so that is the difference lah. Okay, if you're going to make all the port as an input ataupun output, ataupun kamu nak you are going to have the combination for input and output at the same time. Okay, ada soalan? Okay, if no question, next we go to the AVR architecture. Alright, so this is our microcontroller. Okay, so inside of the Atmega32 chip yang kamu beli, okay, kamu dah ada CPU. Okay, dalam ni kamu dah ada CPU, kamu dah ada memory, and kamu dah ada echo. Okay, sudah dapat complete computer system. You have a complete computer system inside of Atmega32 chip. So actually Atmega32 ni dah microcontroller lah. Sebabnya sudah ada CPU, dah ada memory, dah ada input output peripheral. Okay, so the AVR architecture has three main memory space. Okay, macam yang saya katakan tadi, awal-awal tadi, untuk Atmega32, kamu ada tiga jenis memory. Okay, satu kita panggil dia sebagai program memory. Di mana program memory ni tempat kamu nak simpan all the program. Okay, all the instruction you're going to write will be stored here. Simpan instruction ataupun program. Okay, by looking at this figure here, kalau kamu tengok kat sini, okay, yang ni kamu punya CPU, yang ni kamu punya program memory, and this is your data memory. Okay, by looking at this, what type of architecture yang digunakan? Siapa boleh bagi tahu? Okay, kamu ada CPU, lepas tu program memory, and data memory belah sini. So what type of architecture that used by for the Atmega32? Okay, kita guna Harvard ke von Neumann architecture. By looking at this, we using the Harvard architecture. Kenapa? Sebab pun kamu punya data memory and program memory are separated. Okay, dia diasingkan. Okay, ada own buses. Okay, dia ada bus yang sendiri. Okay, dia tak share the same buses. Okay, so that's why AVR is a Harvard architecture. Okay, so kita ada program memory, and then kita ada data memory. Okay, so this data memory kalau kamu tengok kat sini, okay, kamu akan ada RAM. Okay, kamu akan ada I/O registers dan kamu akan ada GPR. Okay, so this GPR ni yang tadilah daripada R0 sampai R31. So, sorry, R31. So this is the GPR, General Purpose Register. And the last memory yang ada ialah EEPROM. Okay, what about the size? Apakah dia punya size? Okay, untuk program memory kita ada 32 KB, RAM 2 KB RAM, and EEPROM 1 KB. Yang ni nanti kita akan tengok. Okay, dia punya size. Okay, so this yang ni dia punya AVR architecture. Okay, you have a CPU dekat tengah-tengah, program memory, data memory, you have a EEPROM, and then these are I/O peripherals lah. Okay, so AVR use hybrid architecture that has a separate buses for the code and data memory. Okay, there are two kind of buses in AVR. One is a program bus. Okay, yang ni program bus yang connect to program memory, we call it as a program bus. Inside of program bus, dia akan ada lagi 3 buses yang itulah. Okay, dia akan ada address bus, okay, akan ada data bus, and ada control bus. Okay, so this program bus provide access to the program flash ROM, okay, which is to communicate between CPU and program. While data bus, okay, so this is the data bus. Yang belah sini is a data bus. We call it as a data bus to bring data to the CPU. All the data from here will be bring to the CPU by using the data bus. Data bus ni pun sama jugalah. Kamu ada address bus, data bus, and control bus at the same time. Okay, and then this is kita punya data memory tadi. Macam yang saya lukis tadi, kita boleh separatekan dia kepada 3 bahagian. Satu is program memory. Okay, so program memory kalau kamu tengok ni, dia punya size is 32 KB. Data memory boleh bahagikan dia kepada 3 bahagian. Okay, so this is GPR. I/O, ada 32 GPR. Okay, ada 64 I/O. And ada RAM. Okay, selalu kita akan guna yang external, internal punya RAM lah. External ni kalau kamu nak tambah lagi. So external ni kita akan discard, kita tengok sampai internal je. So RAM, size of this RAM here is 2 KB. Okay, 2 KB. And then kamu ada EEPROM. Okay, so size of EEPROM is 1 KB. Okay, and then kat sini, kalau kamu tengok kat sini, kamu ada dia punya memory address. Okay, setiap memory ni akan ada memory address. Okay, untuk flash program memory, dia akan ada starting from 000 sampai FM. FM is 3FF lah untuk Atmega32. Okay, untuk RAM, okay, data memory kita akan start with 000 sampailah RAM N kita ialah 085M. So yang ni kita punya RAM N address 085M. Nanti kita akan tengok macam mana kita nak do the calculation, how to do the calculation to get this N address. Okay, and last but not least is our EEPROM. Since our EEPROM is 1 KB, okay, so the starting address is 000 sampailah N address of EEPROM is 3F. Okay, so later we will see more details. Okay, so now we're going to see the program memory dulu, and then after that we're going to see the data memory, and lastly is EEPROM. Okay, so program memory, okay, your flash memory. Okay, so fungsinya store program code. All the code instruction that you're going to write will be stored inside here. So the Atmega32 contain of 32 KB for program storage. Okay, kamu tengok kat sini kita ada 32 KB. Okay, kat sini program storage. Okay, it is organized as 60K darab 60 bit. Okay, so yang bezakan dia, Yang membezakan antara apa ni, program memory, data memory and EEPROM adalah yang ni dia punya size dia 16 bit. Okay, size dia. Data memory size dia only 8 bit. And EEPROM also 8 bit. Okay, yang ni je 16 bit. Okay, flash memory is a 60 bit. Okay, so yang ni dia punya size ni, dia punya lebar yang ni, it is a 16 bit. Okay, for the software security, okay, the program memory or flash memory can be divided into 3 parts. Okay, the first part kita panggilkan dia sebagai reset. Okay, so this is for the reset. Okay, so kat sini tak boleh kacau lah. Okay, part yang ni tak boleh kacau. So this is for the reset and interrupt vector section. Okay, started dari address 000 sampai 02A. Okay, and then we have an application flash section. So application flash section is where you going to store the program code lah. So all the program code will be stored inside here. Okay, dekat kawasan yang ini. Okay, starting dekat address 002B sampailah 3C00. And then last but not least is boot program section. Okay, so this is a boot program, okay, ataupun boot flash section. So this one also is reserved, tak boleh guna. So anything yang kita nak simpan hanya dekat bahagian program code kat sini. Okay, the application flash section. Okay, so this is for the program memory. Ada soalan tak untuk program memory? Any question up until here? Okay, if no question, then we go to the EEPROM. Okay, so Atmega32 contain 1 kilobyte ataupun 1024 byte. Okay, if you ever encounter is 1 kilobyte, it's actually equivalent to 1024 byte. Okay, kalau kamu nak tukar, okay, tukarkan 2 kilobyte kepada bytes. So how to do that? To do that, 2 darab dengan 1024. So kamu akan dapat 2048 bytes. Okay, 10 kilobyte tukar kepada byte. How to do that? So 10 darab dengan kilo is 1024 ya. So 1024. So nanti kamu akan dapat 10,240 bytes. Okay, so this one here is organized as a separate data space in which single byte can be read and written. Okay, so different chip have different size of EEPROM and memory. So untuk Atmega32, okay, the size of the EEPROM is 1 kilobyte. Okay, so EEPROM kita tak akan tengok sangat ya. We are going to focus on program memory and data memory only. Okay, now we're going to look at the data memory. Okay, so the data memory. Okay, data memory yang ni lah, yang tengah-tengah ni. Tak nampak eh? Yang ni. This is the data memory. Yang tengah-tengah dia. Yang ni kita boleh bahagikan dia kepada 3 bahagian, GPR, IO dengan RAM. Okay, so now we're going to look at that. Okay, so this is your data memory. Okay, data memory saya lukis dulu. Okay, so this data memory can be divided to 3 types. Okay, one is a GPR. This one is IO register, and we have a RAM. Okay, kita akan ada general purpose register, GPR, IO register, and RAM. So sekarang ni kita tengok what is a GPR, what is IO register, what is RAM. Okay, so GPR. Okay, so AVR microcontroller have many register for arithmetic and logic operation, but in the CPU, register are used to store information temporarily. Okay, so this information could be a byte of data to be processed or an address pointing to the data to be fetched. So the majority of AVR register are 8-bit register because in AVR only have one data type which is 8-bit. Okay, so kita punya data memory ni, okay, dia punya size dia hanyalah 8-bit. Okay, 8-bit wide. Okay, so now we're going to see the GPR, okay, general purpose register. So with a 8-bit data type, any data larger than 8-bit must be broken into 8-bit chunks before it is processed. So kalau kamu ada 16-bit data, for example, since kita punya ni size is 8-bit, okay, size yang ni 8-bit, so kamu kena divide it daripada 8-bit tambah dengan 8-bit. Okay, contoh kalau kamu ada 10-bit data, so macam mana? Sama jugalah. Mula-mula kamu hantar 8-bit dulu, and then barulah kamu hantar another 2-bit. Okay, kita kena dividekan dia pada 8-bit by 8-bit sebab kita punya size yang ni, register kita hanya 8-bit sahaja. Okay, so in AVR, there are total of 32 general purpose register. Okay, kita ada 32 GPR. Okay, starting from R0 to R31. Okay, kamu ada 32 general purpose register bermula daripada R0 to R1. Okay, so this R0, R31 are located in the lowest location of memory address. Okay, so kalau kita this your data memory, saya ukirkan semula. Okay, data memory consists of GPR, and then we have a I/O and RAM. Since kita ada a total of 32, okay, yang ke atas ni, yang ni adalah kita punya R0, and this one is R31. Okay, and this register GPR is located dekat lowest location of your memory address, which is they akan started with 0000 sampailah 001, sorry, 000. Okay, the question is macam mana nak dapatkan 00 dia punya end address ni? Okay, we can use a formula. Okay, so what are the formula that we going to use? Nak dapatkan value ini. Okay, kita boleh pakai end address sama dengan start address plus size minus with 1. Okay, so kita nak dapat kita punya end address. Okay, we know that the started address is, kita tahu, 0000. What about the size? GPR. Kamu tahu tak size GPR kamu ada berapa? Ada 32. Okay, so you put at 32. Minus with 1. Okay, so 0000 tambah dengan 32 tolak 1, kamu akan dapat 31. But, kamu tengok ni, this is hexadecimal. Yang ni dalam decimal. Tukar dulu, so kamu akan dapat 000 tambah dengan 0F, so you will get 0F. So that's why the value here is 000F. Okay, the end address of R31. Oh, bukan 0F, silap, minta maaf, 1F. Okay, sorry. 1F, not 0F, 1F. Okay, kalau kamu press the calculator, 31 is actually 1F. Okay, kalau 0F baru 15. Okay, 1F is 31. Any question up until here? Ada soalan tak? Any question, guys?
No,
Okay, tak ada soalan. Boleh dengar saya clearly tak? Secara jelas tak? Sebab kat sini hujan lah.
boleh.
Boleh. Okay, bagus. Alright, so sekarang untuk kita punya GPR, since kita punya GPR ada 32. Okay, kita boleh bagikan kepada dua group. Okay, one we call it as a lower register. So saya besarkan sikit lah sebab tak nampak Okay, kita ada lower register. Okay, so daripada R0 sampai R15. So this is your lower register. And we have a upper register from R16 to R31. Okay, so this is upper register. Okay, kenapa ada lower register and upper register? Okay, because some instruction boleh guna upper register saja and some instruction cannot use lower register. But most of the instruction can use a lower and upper. Okay, so kalau kita tengok, for the lower register, work just the rest of the register with the exception of loading immediate. Okay, every time you're going to see the immediate value, okay, to load an immediate value, the value that used to the instruction that going to manipulate the immediate data tak boleh guna R0 sampai R15. Okay, while upper register R16 hingga R31 can access to the immediate data using LDI instruction. Okay, so I kat belakang ni lah immediate data. Okay, so macam mana kita nak kenal sama ada that instruction is immediate, involve immediate data ataupun tak. Okay, so contoh LDI. Okay, so kalau kamu tengok sini, dua-dua instruction ni, okay, have the same function. Di mana kamu nak load satu with the immediate value and satu without immediate value. So kalau every time you see the instruction that ended dengan I kat belakang ni, so you know that this one you're going to use the R16 sampai R31. Okay, kalau instruction that tak ada I kat belakang dia, so kamu boleh pakai daripada R0 sampailah R31. Only the instruction that ended with the I at the back, so you're going to definitely need to use the R16 sampai R31. Another contoh. Okay, SUBI. Okay, so both instruction used to subtract to do the subtraction. Okay, but yang ini since this one here ended with I, so yang ni kita pakai daripada R16 sampai R31. But untuk yang atas ni kita boleh pakai daripada R0 sampai R31. Okay, actually this GPR used here to store the data temporarily. Okay, kita sebagai untuk simpan data sementara saja. Itulah kegunaan general purpose register. So in addition, okay, ada tambahan pula tu. GPR has pointer register called pointer register X, pointer register Y, and pointer register Z. Okay, yang ni kita tukar jadi Z. Okay, so this pointer register is 60 bit. Okay, pointer register adalah 16 bit. So that's why, okay, to make a pointer register X, we need to have 2 GPR. Okay, so R26, R27, yang ni 8 bit, yang ni another 8 bit. So if we combine it together, kita dah dapat 16 bit. So this become pointer register X. Okay, for the pointer register Y, this is R28 and R29. So this is 8 bit tambah 8 bit, we have a pointer register Y. And the last but not least is pointer register Z. Okay, so this pointer register serve as the pointer for indirect addressing mode. Okay, so pointer register X, Y, and Z akan digunakan untuk indirect addressing mode. Okay, later in the module nombor 3 kamu akan belajar about this addressing mode. Okay, indirect addressing mode. How to use the pointer register X, pointer register Y, and Z to move a data from one location to another location. Okay, so to understand of the purpose of general purpose register, two simple instructions as LDI and ADD is used as example. Okay, so kita nak tengok macam mana this general purpose register is work. So kita akan guna these two instructions, which is LDI and ADD. Okay, so LDI instruction. Okay, so this LDI instruction copy 8 bit data to your general purpose register. Okay, so this is the syntax. LDI, RD, and K. Okay, RD is your destination register. Okay, since it is ended with I, so this destination register must be between from R16 hingga R31 sahaja. Okay, while K, so this is your immediate data. Okay, the value from outside. Okay, so this K here kenalah daripada value 0 hingga 255 dalam decimal, or 00 hingga FF in hexadecimal, ataupun 0000 hingga 11111111 in binary number. Kenapa? Sebab this is a 8-bit. Okay, your general purpose register is 8-bit, so kena 8 bit lah. Okay, setiap nombor ni kena 8 bit. So that's why the maximum number is 255. Okay, macam yang saya kata, RT is from R16 to R31. Okay, you cannot load value into register R0 to R15 using LD1 because it is invalid. Contoh. Okay, so we're going to take a contoh. Okay, so this is our data memory. Saya lukislah senang nak nampak. Okay, so this is your GPR, IO dengan RAM. Okay, so now you're going to put value yang ni 25 ke dalam R20. So let's this is R20. Okay, so you're going to put 25. 25 ni daripada immediate value, which is value daripada luar. Okay, you're going to put inside here ke dalam R20. How to do that? Macam mana kita nak buat? Okay, so we can use the LDI instruction. So LDI, what are the destination register? R20. What is the value that you're going to put? 0x25. Okay, after you execute this instruction, what happens is, okay, nombor 25 ni automatically store to R20. Okay, so this is how the LDI works. Di mana I itu stand for immediate value, okay, value daripada luar. Okay, you're going to put to your register. Okay, so kena guna syntax yang betul lah. LDI, R20. Okay, register mana yang kita nak letak and what value that we're going to put. Okay, so what happen here is R20. Sometimes kita boleh tulis macam ni, R20 sama dengan 25. Okay, kalau kamu nampak 0x ataupun $sign, benda yang sama dalam value, that value is dalam hexadecimal. But by default, untuk AVR kita pakai 0x. Okay, so this is the standard lah. Okay, sometimes you can see the $sign, tapi untuk standardize kita pakai 0x untuk represent hexadecimal number. Okay, next kita tengok ADD instruction. Okay, so this ADD to add the value of RR to RD and put the result back into RD register. Okay, so this is an instruction kat situ. Okay, kamu ada ADD, RD, RR. So RD is your destination register, RR is source. Okay, so this is the destination and source. So what happened here? After you execute this line, what happened is RD sama dengan RD tambah dengan RR. Okay, so any value from RD you take and any value for RR you take, add them together and put back to your RD. Okay, contohlah, you're going to add two number, 25 and 34. Macam mana kita nak buat? Okay, so again, saya lukis dulu. Saya punya data memory. So IO and it is RAM. Okay, saya nak tambah dua nombor ni. These two number is outside number. Okay, nombor ni tak ada lagi dalam kita punya register. Okay, since these two number is not inside of our register, so what you're going to do is we need to put this number to our register and then after that barulah kita tambah. We cannot simply use the ADD, okay, 0x25, 0x34, which is wrong. Tak boleh sebab dia punya syntax ialah mesti daripada destination register and source register, which is our GPR. So kita tak boleh guna yang ni. Directly tambah tak boleh numbers. Okay, so kita kena masukkan dulu nombor ni ke dalam GPR, the second number to our GPR, and after that barulah kita boleh guna instruction add. How to do that? Okay, contohlah dalam contoh ni, okay, let's see is our R16 and this is our R17. Okay, we are going to use the R16 and R17 to load the value. So what happen here is 25, okay, you're going to put to R16 and 34 kamu kena load dalam R17. So how to write down the instruction? Okay, so just simply lah LDI R16 with 0x25. So what happen here? After you execute this line here, nombor 25 akan disimpan dalam R16 and load I R17 0x34. So automatically 34 akan disimpan dalam R17. So next, what we going to do? Barulah kita tambahkan dia by using this instruction. So ADD, okay, R16 R17. So what happen here? 25 kita tambah dengan 4, which is this hasil dia 59 akan disimpan dalam R16. So after you execute this line, so R16 sekarang ni bukan lagi 25. Okay, so dia dah dapat value yang baru iaitu 59. Okay, boleh? Any question?
Doktor nak macam R16, R17 tu kita yang letak nama ke atau macam mana?
Kita yang decide sendiri. Register mana yang kita nak pakai. Okay. Tapi kamu boleh pakai daripada ni lah. Okay, make sure kamu pakai daripada R16 sampai R31. Sebabnya kenapa? Sebab kamu kena load dulu value ni ke dalam register kamu. Okay, dalam example ni saya pakai R16, R17. Kamu boleh pakai R20, R21 ke, R21, R25, tak kisah. Any register.
Okey, Pak.
Okay. So any question? Any other question? Soalan lain ada lagi tak? Okay, if no question, I'm going to apa ni? Okay, so kita dah habis bahagian GPR. Okay, yang ni kita dah tengok. Okay, dekat atas ni kita dah tengok GPR. So what is the function of GPR? Now we're going to see the IO register yang tengah-tengah ni. Okay, yang kat tengah-tengah ni. Apa itu I/O register? Okay, so the I/O register is dedicated to specific functions such as status register. Okay, ataupun kita nak take a break dulu, and after that we continue back. Macam mana? Kamu nak sambung terus ataupun nak stop, nak take a few minute breaks dalam 10 minit ke, and then we continue back. Anyone?
Few minute break.
Okay, kita ambil break, kita break dulu ya. Okay. So kita sambung semula pukul 4 berapa nak? 4.40, boleh tak?
Boleh, Doktor.
Okay, 4.40 ya. Kita sambung semula 4.40. Okay, just now we stop at the I/O registers. Okay, kita dah tengok GPR. Now we're going to see the I/O registers. Okay, which is this I/O register is inside the data memory. Okay, boleh dengar saya? Semua boleh dengar saya? Asfawati boleh dengar tak saya cakap?
Doktor.
Okay, great. Okay, so the I/O register is dedicated to specific functions such as status register, timers, serials, communication, I/O port, ADC, and etc. So this I/O register is used to store the value, okay, that are going to do a specific functions lah. Okay, so this function of each I/O register location is fixed by the CPU designer. Okay, so the location dah fix, kita tak boleh tukar. Sama juga dengan GPR tadi, the location is fixed, di mana kita letak dia on the top, dekat atas sekali of our data memory. Okay, so the number of allocation in the data memory set aside for I/O register depend on the pin numbers and peripheral functions supported by that chip. Okay, for Atmega32, okay, there are total of 64 byte of I/O register location called standard I/O register. Okay, tadi kita lukis balik dulu kita punya ni. Okay, so this is our GPR. Kita ada GPR, kita ada 32 GPR. Okay, which is starting from 00, address 000 sampailah 001F, and then this is I/O register. Okay, I/O kita ada 64 I/O register which is starting from 0020 until alamat 005F. Macam mana nak dapat 005F? Okay, you can use the same formula di mana okay, end address sama dengan start address, okay, plus size minus 1. Okay, in which in this here, okay, the start address adalah dekat alamat 20. Tadi kan start address of GPR is at 00. Now the start address is alamat 0020. And what are the size? Kita ada 64, so you just put the 64 there minus with 1, and then you will get 0020 tambah dengan 63. So since this one here in decimal, so you need to convert to hexadecimal, so that after you convert to hexadecimal, you tambah dengan 20, you will get 005F. Okay, so this is the end address of the I/O registers. So this is the 64 I/O registers, as you can see inside of this table. Okay, the special part of I/O register, dia ada dua memory address. Okay, dia ada dua address. One called as a I/O address, the other one called as a memory address. Okay, for the memory address, dia punya starting address adalah daripada 20 sampai 5F. Okay, yang ni 5F ya. Sampai 5F. So yang saya lukis ni tadi, okay, this one. So this one is refer to, yang ni kita refer to memory address. Okay, so lukis, saya kena lukis balik semula, setiap kali kena lukis. Okay, so I/O dia punya starting address adalah 0020 sampailah 005F, di mana kamu ada total of 64 lah kat sini. Okey, yang ni 20, kalau kamu tengok 20 sampailah and address is 5F. Okay, so dekat 20 ni akan ada ni lah. This is the IO register name. Kamu akan ada TWBR, TWSR, and Centra. Okay, so in this class ni kita akan fokus dekat sini je. Okay, ADC, okay, sorry. Okay, kita akan fokus yang ni. Okay, yang ni untuk ADC. Okay, and then we have mana lagi? Okay, yang ni. Oh, banyak ni. Daripada sini sampailah ke sini. Okay, pin D, DDRD, port D, pin C, DDRC, port C, until pin A, DDRA, port A. So this is our IO ports. Okay, this is our IO ports. Kat sinilah dia punya location dia. And then next is yang ni. Starting from here until sini. Okay, so this is for timer register. And last but not least, yang ni. Okay, ada ni, better kita lukis dia ni lah. Okay, yang mana saya highlight ni. Okay, so this one is belong to what we call here. This one is intra. And last but not least, yang last ni, this is your status register. Okay, status register. And yang ni area adalah kita punya stack pointer. Okay, so this is the IO register yang kita akan belajar dalam kita punya Atmega32 class. Okay, yang lain-lain tu kita just ignore je. Okay, so later kamu akan tengok lah the function of this IO register. Okay, next, last but not least, kita dah ada tadi, we are already learned about the GPR, kita ada IO, and then now we are going to focus on this RAM, okay, which is we call it as an internal data SRAM. So this internal data SRAM widely used for storing data and parameters by AVR programmer and C compiler. So yang ni kita nak simpan kita punya data. All the data will be stored inside the RAM lah. Okay, tadi GPR is temporary storage data. RAM also another temporary storage data. Okay, but this RAM here, okay, dia tak selalu digunakan compared to GPR. Okay, so each location of the SRAM can be accessed directly by its address. Okay, kita boleh access data-data dalam RAM ni menggunakan dia punya apa ni addresses. Okay, di mana? Okay, kalau kita tengok kat sini, okay, the starting address of RAM is 0060. Jadi 5F, so starting dia 00650 sampailah RAM N. Okay, this is the N address of our RAM. The persoalan is, what is our RAM N? The RAM N is depend on the size of our RAM lah. Okay, in this Atmega32, size of RAM ialah 2 KB. Okay, so macam mana kita nak dapatkan dia punya RAM N, the N address of RAM N kita? RAM kita. Okay, kalau kita tengok sini, the N address is 085F. So kita use the same formula. Okay, N address sama dengan start address tambah dengan size minus with 1. Di mana start address kita adalah 60. Okay, untuk RAM, start address is 60 tambah dengan size. Okay, so this is a 2 KB minus 1. Okay, so macam mana kita nak tukar this 2 KB kepada byte? Okay, I already mentioned earlier. So this one here, you need to multiply 2 kilo. Nak tukar kilo, you need to multiply with 10 to 4 minus with 1. So kamu akan dapat 0060 tambah dengan 2048 tolak 1 2047. Okay, convert this value to hexadecimal, so kamu akan dapat 2047. Siapa ada calculator? Sekejap, saya check. Can you tell me what is a 2047 dalam hexadecimal? 2 hex. which is equivalent to 07FF. Okay, so this is a 7FF. When 7FF tambah dengan 60, kamu akan dapat berapa? Tekan calculator. 60 tambah 7FF. Okay, 60 tambah dengan 7FF, so kamu akan dapat okay, 08 5F. Okay, so this is sama dengan dekat sini 08 5S. Okay, so this size of RAM can be vary from chip to chip lah. Okay, untuk Atmega32 dia punya size RAM adalah 2 kilobyte. Okay, kalau kau pakai Atmega8 1 kilobyte, 64 4 kilobyte, dengan yang ni Atmega 1 to 8 is 8 kilobyte. Okay, any question up until here sampai RAM? So ingat, every time you heard the word RAM end, so the address is 085. Okay, so we need to remember this value here. Okay, to summarize, so this is the ni lah kita punya AVR architecture. Okay, so we have a program memory, then you have a data memory. Data memory can be divided into 3. You see GPR, okay, kamu ada 32 GPR, you have a IO, and you have a RAM kat sini, and then followed by EEPROM. Okay, and then this what we call here, this address here, you can calculate by using the formula. N address sama dengan, okay, so you need to remember lah, N address sama dengan start address minus 1, plus size, okay, minus with 1. Okay, you need to remember this formula. Okay, contohlah kita nak dapatkan what is our N address of this flash here. Okay, program memory. Okay, so N address untuk program memory. The N address sama dengan, what is the start address? Start address adalah 000. Okay. Tambah dengan size, what is the size of our flash address? 32 kilobyte. Okay, so 32 kilobyte minus with 1 byte. Okay, there is a byte untuk program memory. Since this program memory, kalau kamu recall back, this is a 16 bit. Yang ni 8 bit. Okay, and then this is a 8 bit. Okay, you know that 1 byte sama dengan 8 bit. Since this is a 16 bit, so you need to divide it by 2 lah kat sini. Kena bahagi dengan 2. Okay, so kamu akan ada 0000 tambah dengan 16 kilobyte minus with 1. Okay, so bila kamu tambah tu, kamu akan dapat, anyone, saya tak ada calculator lah, boleh tekan tak? Boleh bantu? Anyone? Okay.
16384.
16384. Okey, 16384. Ini dah tolak dengan 1 ke belum lagi?
Belum lagi.
Belum kan? Okey, belum. So sama dengan 16383, and then kamu tukarkan dia kepada hexadecimal, kamu akan dapat berapa? Satu enam tiga lapan tiga tukar kepada hexadecimal, so kamu akan dapat 3 F. Okey, so samalah dengan jawapan kita. Okey, cuma yang ni je. Kamu kena bahagi dengan 2. Untuk program memory, you need to divide it by 2. Kenapa divided by 2? Sebab size kat sini, sebab yang ni 16 bit. Okey, 1 byte adalah 8 bit. So, that's why you need to divide it by 2. Okey, yang lain just follow the same formula. Okay, any question? Ada soalan tak? Okay, so now in the next few slide, kita akan tengok a few instruction, okay, that involve the data memory. Okay, some of involve the I/O register, some involve the RAMs. Okay, so earlier we saw a simple example of using LDI and ADD that use immediate value of K and the GPR. So LDI and ADD are use the GPR in order to do the data processing. Meanwhile, the AVR also allow direct access to other location in the data memory. Contohnya dalam RAM. Okay, so this is your one tadi. Okay, so kita balik semula lah. Okay, so kamu ada GPR, kamu ada I/O, kamu ada RAM. Okay, kalau kamu nak load data, okay, from outside to your GPR, okay, outside value from GPR, you can use the LDI instruction. But let's say lah value tu ada dalam RAM. Okay, that value inside of the RAM, kamu nak masukkan dia ke dalam GPR. How to do that? Okay, so in this case here, we need to use the LDS instruction. Okay, daripada RAM kepada GPR, we use the LDS instruction. We have a few instruction lah. Okay, contoh kalau daripada I/O, okay, value tu daripada I/O register kat sini. Okay, nak masuk ke dalam GPR. Okay, how? Yang ni kita pakai in instruction. In instruction. Okay, so later we will see all these instruction here. Okay, yang ni daripada ni nak masuk ke dalam GPR. So daripada GPR nak pergi ke contoh nak simpan balik semula ke dalam RAM, daripada GPR nak simpan ke dalam I/O. So there are few instruction involved. Okay, ada few instruction. We go more detail in the next few slide. Okay, so the first instruction here, data memory. Okay, so LDS instruction. So this LDS instruction stand for load direct from data space. Tell the CPU to load copy 1 byte from an address in the data memory to GPR. Maksud sekarang ni, dia nak copy value from GPR or value from this data memory, tak kisahlah sama ada value tu from I/O ke, dalam RAM ke, atau dalam GPR itself, okay, to your GPR, because this is a data memory. Okay, so we can use the LDS instruction. Okay, so the syntax here is LDS RDK, di mana RD is your destination register. Okay, so since this is not involve the immediate value, so RD boleh daripada R0 sampai R31. Okay, you can use any register. Okay, while K, this K here actually your memory address. Okay, the address between 0000 sampailah 085F. Kenapa 085F bukan sampai FFFF? Sebab from the calculation earlier, kalau kamu buat calculation ni, kamu punya RAM N ni. Mana kita punya calculation tadi? Okay. Yang ni. Okay, kamu dah klik tadi, kamu punya RAM N, okay, is 085. Okay, starting daripada sini sampailah sini, which is 0.85. Okay, so example. Okay, you're going to load R5 to the content of location 200. Okay, kamu ada ni. Okay, so this is your RAM. Ni alamat 200. Okay, add ada value. Okay, tak kisahlah apa-apa value dalam ni. Yang penting is hexadecimal. Okay, now you're going to load this value and put it to your R apa ni? R5. So how to do that? Okay, to do that, we can use the LDS instruction, which is LDS. Okay, what is the destination register? The destination register kita adalah R5. So you put R5. Okay, what is the K? Okay, the location. The location is coming from OX 200. So what happened is, dia ambil pergi ke address 200, take the value inside there and put to R5. After you execute this line here, what happened? The R5 will have this value from address 200. Okay, so let's look at another contoh. Add the content of location 300 with a location 302. Okay, kamu ada value daripada alamat 300, okay, dengan 302. Contohlah, this is a 302. Dekat sini, you want to add this number here. Tak kisah pun number ni apa-apa. Saya just put a variable XX, YY. Okay, so how to do that? Macam mana nak buat? Okay, first, what you're going to do is, okay, kita kena ingat. Okay, recall back kita punya ADD, address, ADD instruction. Okay, the ADD says that RD with RS. Okay, ADD melibatkan destination register tambah dengan source register and put back the result into the destination register. Okay, so 300 dengan 200 ni, is it a register yang ni? Bukan, because this one here inside of your RAM. Okay, yang ni RAM. Kat sini, this is your RAM, not inside of your register. So tak boleh directly, you cannot simply put something like this. 300 dengan, sorry, tak boleh, invalid. Okay, because this is a address RAM. Okay, dia hanya boleh guna daripada GPR. Okay, add daripada GPR with a GPR. So how to do that? Macam mana kita nak buat? Okay, untuk buat, okay, what you going to do is, you need to load dulu lah. Ambil yang ni, masukkan dalam kamu punya GPR. And then ambil this value from address 302, masukkan dalam GPR. And then after that, barulah kita boleh tambah. Okay, so we just lah. Okay, why not we put, okay, use the LDS. Okay, first kita letaklah yang ni dekat R, berapa kita nak letak? R17. Okay, yang ni nak letak dekat R18. Tak kisah pun mana-mana R. So LDS R17 with a value from address 0x300. So 300 masuk ke R. Value from 300 masuk ke R17. So kamu ada SX kat situ. Okay, and then another LDS. So yang ni tadi tak boleh R18. Okay, coming from address 302. So yang ni kamu masukkan ke dalam R18. And then barulah kita boleh buat addition. Okay, sebab yang ni based on this syntax here, ADD RD RS. So R17 R18. Tak kisah, kamu nak letak R18 R17 pun boleh. Okay, sebab dia tak bagi tahu pun nak letak dekat register yang mana. Okay, so this is what happened lah. Okay, kalau kita tengok kat sini, okay, yang ni dia guna R0 daripada 300. So, apa yang berlaku? Pergi ke address 300. Okay, so this is address 300. Ambil the value and put to your R0. And then there's the second line here. LDS R1 300. So, pergi ke address 302. So, this is address 302. Ambil value inside here. Put to your R1. Lepas tu, ADD R1 R0. So, apa yang berlaku? R1 sama dengan R1 tambah R0. Okay, so this is the LDS instruction. It means that we're going to load the instruction. We're going to load the value from data memory. Okay. Any question? Ada soalan tak? Up until here.
Belum lagi.
Belum lagi ya. Okay, so boleh follow lah. Okay, so far boleh follow. Good, great. Okay, now we are going to see the STS instruction. Okay, tadi kita dah tengok LDI, kita dah tengok LDI, LDS. Now we're going to see the STS. Okay, so STS instruction. What does STS do? Okay, so STS store direct to data space. Okay, so now we are going to store the data from GPR masuk ke dalam kita punya memory address. Okay, so instruction tells CPU to store the content of GPR to an address location in data memory. So this is the syntax. Okay, STS KRR. Okay, don't worry. Okay, so yang ini kamu tak perlu hafal pun dia punya instruction. Okay, because why? Sekejap ya. Okay, you have a lot of instruction. Banyak sangat instruction, tak perlu hafal. Okay, so this instruction here akan diberi. Okay, so this is the instruction yang kita ada. And this instruction will be given in the final exam as well as in the test. So you no need to hafal this instruction. Okay, from this instruction set summary, kamu boleh lihat, okay, kat sini, kamu ada dia punya mnemonics, kamu ada operands, okay, kamu ada mnemonics, operand, and this description and as well as the operation. Okay, kalau kamu tengok sini, ADD, operand dia adalah RDRR, okay, RDRR. So you know that destination and source. Apa yang dia buat? Add without carry. Apakah operation dia? Boleh tengok kat sini. Kita boleh tengok je kat sini. Oh, this is the operation. RD sama dengan RD tambah RC. Okay, as long as you know that how this operation works untuk setiap instruction, so tak ada masalah. Okay, kita tengok tadi LDS. Mana kita punya LDS tadi? LDS. Okay, this is a LDS. Okay. RD small k. Okay, which is load direct from data space. So what happened here? Okay, dia pergi ambil value daripada small k ni, which is your address, data memory, get that value and put to your RD. Kalau LDI, RD capital K, load immediate, means that you're going to take the value, okay, given by K and put it to your RD. Okay, so this instruction set will be given lah, akan diberi. Okay, no need to memorize. Okay, so after the instruction is executed, the location in the data space will have the same value as GPR. Okay, contohlah, store the content of R25 to a location 230. Okay, lukis lagi sekali. Okay, so this is your data memory. Ada 3 location. So this is R25. Okay, contohlah dalam R25 ni ada value 1F. Okay, so now I'm going to save this value. Okay, save it inside of my RAM dekat alamat 230. So how to do that? Macam mana kita nak buat? Okay, so you just simply lah use the STS. Okay, K. K is your destination address. So X 0x230. Okay, the alamat, the tempat yang kamu nak simpan. And RR is your source register. What is our source register? R25. So what happen? After you execute this line here, so alamat 230 ni akan ada value 1F. Okay, so value 1F dekat R25 tak berubah, masih sama. Okay, another example. Load the R60 register with a value of 55, then move this value around I/O register port B, port C, and port D. Okay, now dia dah jadi makin kompleks. Okay, kamu ada value 55. Kamu nak hantar dia ke port B, port C, and port D register. So, how to do that? Macam mana? Okay, so nombor 55. So, 55, this is immediate value. Kamu nak hantar dia ke dalam I/O register. Okay, contohlah dia is a port B, port C, and port D. So how to do that? How to send out this 55 to this register here? Okay, first thing first, what you going to do? Apa yang kita kena buat? Since this is an immediate value, okay, data daripada luar. So what you going to do is you need to load this data to your GPR lah. Okay, letak, masukkan dia dalam GPR. Contohlah kita pakai R16. So that's why LDI R16 0x55. So LDI R16 0x55. So what happen here is R16 ada nombor 55. So now barulah kita boleh hantar ke sini. Port B, port C, and port D by using SCS instruction. But the persoalan is, apakah dia punya memory address? What is the address of this port B, port C dengan port D? Siapa nak bantu? Apakah dia punya address? Okay, by looking at this I/O register yang kita dah belajar tadi. Okay, so this is I/O register. Mana kita punya? Okay, port D. Okay, this is a port D. Okay, saya highlight kan. Okay, so this is your port D. Alamat port D adalah 32, port C 35, dan port B alamatnya 38. Okay, so kita kena pakai alamat ni. Okay, the memory address punya alamat 32, 35 dengan 38. Okay, so now you know that. Okay. So this is alamat 0038. This is alamat F0032. And this is alamat 0035. So barulah kita boleh hantar. Macam mana nak hantar? So STS. Okay, hantar dulu 0x03, okay, 0038. Okay, with R16. STS 0x0035. Okay, R16 and STS 0x0032 R16. So automatically value from R16 which is 55 kamu simpan dalam port B, port C, and port D. Okay, boleh. Okay, next is in instruction. Okay, so this in instruction tells the CPU to load 1 byte from IO register to GPR. Okay, yang ni hanya fokus on IO register. Tadi kita data memory. Kalau LDS, STS kita datanya data memory. Tak kisahlah data tu daripada IO register ataupun RAM ataupun register itself. But untuk yang ni, ini hanya untuk IO register masuk ke dalam GPR. Okay. So after the instruction is executed, the GPR will have the same value as IO register. Okay, as I mentioned earlier, each location in IO memory has two address. Satu is the data memory address, the second one is IO address. Okay, kalau data memory kita akan guna instruction seperti LDS, STS. Kalau IO address kita akan guna in dengan out instruction. Okay, in untuk ini similar to LDS lah. Out sama dengan STS, tapi kita guna address yang berbeza. So in instruction, the IO register are referred by the IO address. Okay, macam yang saya tunjuk tadi. Yang ni, nampak ni? Kamu ada dua kolom kat sini. Satu IO address, satu memory address. Okay, yang ni kita guna LDS, STS. Kalau pakai IO address, kamu kena guna in and out instruction. Okay, so tak apa, kita tengok line by line. Okay, example. Load R19 with the content of location OX10 of the IO memory. Okay, so how to do that? Okay, kamu nak load value daripada ni. Okay, so contoh. So this is R90 and this is the address of 0010 dalam IO. Okay, kamu nak load value daripada sini masuk ke dalam R19. How to do that? So you just use the in R19 and then followed by the address is 110. So what happen here? So kamu akan ambil value daripada address 10, which is this is IO address. Yang ni IO address refer to IO address not memory address masuk ke dalam R19. So automatically R19 we have the value same value as alamat 0010 dalam IO address. Okay, so this is the ni lah. Okay, saya besarkan sikit bagi nampak. I zoom in. Okay, as I mentioned earlier, macam saya bagi tahu tadi, untuk IO kamu ada berapa total of IO? Kamu ada 64 IO. Okay, daripada 64 IO ni dia ada dua address, satu IO address, satu lagi memory address. Okay, untuk IO address dia punya starting address dia adalah daripada 00 sampailah 3F. Manakala untuk memory address dia starting from 020 sampailah 5F. Okey, berbeza ya. Okey. So yang ini IO address kamu boleh pakai in ataupun out instruction. Yang ini kamu boleh pakai LDS ataupun STS instruction. Okay, so this is the register name lah. Ada register name tadi saya dah tunjukkan yang mana kita nak guna dalam kelas ini. Okay, so to work with IO register more easily, okay, we can use their name instead of their IO address. Okay, kita the advantage by using the in instruction, okay, in dengan out instruction, kita tak perlu pun ingat dia punya addresses. Okay, the IO address. Kita boleh pakai je dia punya nama. Okay, so this is the nama. Okay, yang ni kita pakai je dia punya nama. More than enough. Tak perlu pun ingat dia punya IO address ni, tak perlu ingat. Kita pakai nama pun dah boleh. Tapi untuk memory address, kamu tak boleh guna nama dia. Kamu kena pakai dia punya address value. Okay, so that is the difference between in and out instruction with LDS, STS instruction. Okay, contoh. Load R19 with the content of pin D. Okay, so you just simply write in R90 pin D. Okay, sama juga kalau kamu tukar, okay, which is similar. Kalau kamu pakai, kalau kamu tak nak guna dia punya nama, okay, you can use the IO address by using in R19. Okay, what is the pin D punya location? Okay, kamu carilah daripada sini. Pin D location. Where is a pin D location? Okay, so here. Okay, dia adalah dekat alamat 10. Okay, you just simply put the 0x10. Okay, so this is a similar lah. Okay, kamu tak nak pakai in instruction, kamu nak pakai LDS instruction pun boleh. So you just simply write LDS R19. But now we need to refer to this data memory, this memory address. Okay, so 0x30. So benda yang sama. Okay, yang ni pun sama dengan. Okay, so in R19 pin D. Okay, yang ni tanpa ingat, tak perlu pun tahu dia punya address, kita just use the name. Ataupun kamu boleh guna in R19 with the addresses, the IO address. Ataupun you can use the LDS R19 with OX30. Okay, so ketiga-tiga ni benda yang sama di mana kamu nak load R19 dengan konten daripada pin D. Okay, so what happen here, R19 akan ada value daripada pin D. Okay, ada soalan? Up until here, ada soalan tak? Anyone? Okay, if no soalan, okay, next we move to another instruction, okay, called out instruction. Okay, so out to IO location instruction tells CPU to store GPR to IO register. Okay, this is a similar, lebih kurang sama dengan STS instruction. But for out, kita kena pakai IO addresses ataupun dia punya nama. Okay, so this is the syntax. Out ARR. After the instruction is executed, the IO register will have the same value as a GPR. So this out instruction, the IO register are referred by the IO address. Okay, contoh. Copy E6 to SPL register. Okay, so this is your data memory. Okay, GPR, IO, and RAM. Okay, contohlah SPL kamu ada dekat around here. This is your SPL. Okay, macam mana kamu nak masukkan value E6, okay, which is value from outside to SPL. How to do that? Can you directly ambil value ni masukkan dalam SPL? Tak boleh. Okay, sebabnya from here you see ya. Kalau dari sini kamu kena out ARR, kamu kena ambil value daripada GPR masuk ke dalam kamu punya IO address. Okay, so what you're going to do is first ambil value ni masuk dalam GPR. Okay, and then from this GPR baru pergi ke SPL. So kamu ada dua step lah kat situ. Okay, how to load this E6 kepada GPR? Okay, by using the LDI. R berapa nak pakai? R20 lah. 0x E6. So what happened here? R20 sudah ada value E6. So value from here you can transfer to SPL by using the out. So out, what is the SPL? Okay, so kena refer balik lah. SPL. Kita boleh pakai dia punya names, okay, the register name. Okay, kalau pakai register name, you simply write down SPL R20. Ataupun kalau kamu tak nak pakai yang ini, okay, atau, so saya tulis atau atau you can use the out Okay, you need to figure out what is the SPL, address of SPL. SPL, so this is a SPL. Yang ni this is your SPL 3D. Okay, so you can simply write out 0x 3DR20. Benda yang sama. Ataupun tak nak pakai out instruction, you going to use the STS instruction pun boleh. STS 0x5DR20. Okay, kenapa 5D? Sebab tadi kita dah check dah. Okay, nampak ni 5D untuk pakai refer to memory address. Okay, so another example. Okay, you're going to copy pin D to port A. How to do that? Macam mana kita nak copy pin D to port A? Okay, value tu ada dalam pin D. Okay, contoh dia is ni, dia ada dalam ni. Value ada dalam pin D. Kamu nak masukkan dia ke dalam port A. So, how to do that? Nak masuk ke sini. How? Boleh tak kita directly dari pin D pergi ke port A? Tak boleh. Kenapa tak boleh? Sebabnya, all the instruction kita belajar tadi, dia kena melalui GPR. Kamu kena pergi ke GPR dulu. Okay, from that GPR barulah pergi masuk ke port A. Okay, so daripada sini nak pergi ke GPR guna apa? In instruction. So in R0, for example, pin D. So what happen here? Value from pin D akan disimpan dalam R0. Okay, so from here, R0 barulah kamu boleh masuk ke dalam port A by using the out instruction. So out port A R0. Okay, so that is. Any question? Ada soalan tak? Unclear? Tak ada lagi ya? Okay, good, great. Okay, so saya nak tanya, kamu punya programming skill macam mana? Okay ke? Biasa-biasa saja ke? Ataupun kurang?
Kurang.
Kurang. Okay, so kurang tu kena fokus banyak lah ni. Okay. Sebab nanti, sebab apa ni, kita punya kelas ni more on the programming part lah. Okay, so you need to focus more in order to excel in this course. Okay, so that is for the out instruction. Tak apa, yang ni nanti kita akan, in the next module pun kita akan sentuh sikit-sikit pasal instruction yang ni nanti. Tapi that one I akan go more quickly lah. Alright, so next, move instruction. Okay, MOV. Okay, so this MOV instruction used to copy data among GPR register. Di mana kamu nak copy daripada satu GPR to another GPR. Contohlah saya bagi kat sini. Okay, so this is your data memory. Okay, kamu ada value. Okay, from R17 contohnya. Kamu nak masukkan R0. So contoh value kat sini saya letak 57. Okay, this value here you want going to copy to R0. So how to do that? We can simply use the MOV instruction. Okay, so what the MOV do? Okay, this is the syntax lah. MOV RDRR. So what happened here? So RD is destination, RR is your source. Okay, since this one here, kita nak copy daripada R17 masuk ke R0. R0 lah. And our source is from R17. So what happened? After you execute this line here, so 57 sudah di copy ke dalam R0. Value dalam R17 masih lagi ada ke tak? Masih lagi remain. Okay, dia tak berubah. Masih lagi ada 57. Okay, another example. Copy the content of R20 to R10. Okay, so this is R20 for example. Ada XX value. You're going to copy it to R10. So how to do that? Okay, just simply use the MOV. Okay, what is the destination? R10. What is the source from R20? So automatically what happen here is R10 akan sama dengan R20. Dia punya content, dia punya value inside of that register. Okay, so that one is for move lah untuk copy data from one register to another register. Okay, so more ALU instruction involving the GPR. Okay, kita ada, as I show you earlier, kita ada banyak instruction. Okay, so this is some of them lah. Okay, we have the INC instruction. Okay, so this is INC instruction used to increment the content of RD register by 1. Okay, so setiap kali contohlah kalau kamu nak increment your register by 1, you can use the INC instruction. Okay, so this is the syntax INC RD, di mana RD can be from R0 to R31. Okay, example, add 1 to the content of R2. Okay, kamu nak buat R2 sama dengan R2 tambah dengan 1. Okay, so kamu ada two way of solution here. Okay, the first one is the longer one, the second one is the shortest one. Okay, we do the longer one lah. Okay, so first, this is a 1. 1 is an immediate value, betul tak? So you need to put the LDIR16 1. Okay, masukkan dulu value 1 ni ke dalam R16 and then barulah kamu tambah dengan value from R2. So ADD R2 with R16. So what happen here after you execute kat sini, R2 sama dengan R2 tambah R16, di mana R16 kamu sama dengan 1. So this is the longer way lah. Okay, the shortest way is you can simply put increment R2. Okay, one line instruction. Compared to this one, you need 2 instruction. Okay, so another example, increase the content of data memory location dekat alamat 430 by 1. Okay, so kamu ada, so this is your memory address, data memory, GPR dengan IO. Okay, the persoalan here is kamu ada value dekat alamat 430, tapi kamu nak increase this value here by 1. So macam mana nak buat? Okay, contohlah value asal kat sini saya letaklah dia 47. Okay, kamu nak increase 47 ni supaya dia jadi 48. So how to do that? Macam mana nak buat? Okay, can we simply put the INC OX430? Boleh tak kita buat macam ni? Tak boleh. Kenapa tak boleh? Because INC, okay, if you can see here, hanya involve the GPR. So what you going to do? Okay, mula-mula kamu ambil value ni, masukkan dalam GPR. Okay, and then from there, you increment lah dia by 1. Okay, so this is second step. After you increment by 1, then after that you simpan balik ke dalam this location. Okay, that's why kalau kamu tengok ni LDS R20430, so masukkan dulu value 47 ni dalam R20 and then increment R20 by 1, so 47 tambah 1 dah jadi 48. So this is 48. Okay, so this is R20 and then after that from here you masukkan balik dalam 430 dengan menggunakan STS instruction. Okay, so this is the increment. Okay, so increment means that you're going to increment the value inside the register by 1. Okay, then if you're going to decrease the value in the GPR by 1, so you can use the decrement instruction. Okay, so DEC. Okay, so this is the syntax DEC RD, di mana RD sama dengan RD minus 1. So RD ni can be from R0 to R31. Okay, example, subtract 1 to the content of R10, so you just simply put DEC R10. Okay, another example, put the value 3 into R30. Okay, so kamu ada ni. Okay, kamu ada nombor 3 from outside. You're going to put it to R30. So this is your R30. Masukkan kat sini. And then after that, you're going to decrement it berapa kali? 3 kali. So how to do that? Okay, the first step, since this is a value from outside, nak masuk ke R30, so you're going to use the LDI lah. So LDI R30 with 3. Okay, masukkan 3 dalam 30, so automatic sini akan dapat 03. Okay, after you execute this instruction, 03 akan disimpan dalam R30, and then you're going to decrement this value here how many times? 3 times. So DEC R30, DEC R30 dah 2 kali, and DEC R30 dah 3 kali. So after you execute the last instruction here, what happened to your R30? Apakah value R30? So now R30 value dia adalah 0. Okay, another instruction is called as SUBs. Okay, SUBs used to subtract, okay, the value from RR from RD and put the result back into the RD register. So this is your syntax SUB RD RR, di mana RD sama dengan RD minus RR. Contoh, subtract 25 from 34. Kamu ada 34, kamu nak tolak dengan 25. How to do that? How are you going to do? Okay, first kita kena letaklah ni dulu. Okay, you're going to load this value to your register. So this is R16 and this is R17. Okay, and then from there you can use this instruction here as SUB RD RR. Okay, so LDI R16 0x34 LDI R12 0x25. And then here kat sini penting. Okay, kamu kena tengok yang mana satu kamu nak subtract. Is it R16 tolak R17 atau R17 tolak R16? In this case, R16 tolak R17. So SUB R16 R17. Okay, so next, subtract 5 from content of 300 and store 320. Uang nak simpan dalam alamat 320. Okay, kamu ambil value dekat alamat berapa ni? 300. Okay, dalam ada nombor 5. And then after that, okay, any value from here, and then you're going to subtract it, and then rest kosong 2. Okay, so how to do that? Macam mana buat? Okay, first 5 ni dah ada ke belum? That's why lah. Okay, this is the second step, masukkan dia dalam register, and then after that barulah kamu boleh buat subtract. Okay, in which the subtract is from register to another register. Okay, so dari 302. Okay, so what we're going to do is first kita load dulu value ni 5 masuk ke kita punya register. So LDI R20 with 5. Okay, so what happen? R20 sama dengan 5. And then this one ya, 300 nak masuk dalam register, what instruction that you're going to use? Instruction apa kita nak pakai? LDS. So LDS R0 alamat 300. Okay, saya pakai 0x lah. Sebab nak X value alamat 3 kosong. And then baru subtract aku. So what happen? R sama dengan R. Tolak tadi ada row, the result is going to happen. So kosong. Okay, R kosong. ADC, AND do a logical AND, EOR do a logical exclusive OR, EOR do a logical OR, SBC, SUB. SBC is stand for subtract with a carry. Nanti kita akan belajar lagi more details on the next chapter. Okay, and then this is a CLR, OM do the one complement, NEG do a negative or second complement, ROR rotate left, ROR rotate right. Okay, this one we will learn in the module 6. Okay, so now the last slide here that I'm going to show you is the AVR status register. So this is a more important. Kita punya AVR status register ni ada dalam kita punya IO register dekat sini. Okay. This one ya. Alah, tak nampak. Okay. So this kenapa jadi kat sini. Anyone? Okay, so kalau tak ada soalan sekejap. Okay, for those yang baru join and then tak sign lagi kedatangan untuk hari ini. Okay, please do so by Aswawati. Dengar tak Aswawati? Sekarang dengar tak? Clear tak? Saya punya audio.
Ya, Doktor.
Oh, ya ke? Daripada pukul berapa tadi intermittent? Ke baru lagi?
Baru dalam 5 minit ni.
Okay, so sekarang macam mana? Okey tak?
Setakat ni okey ni.
Okay. Alhamdulillah. Nanti kalau ada apa-apa bagi tahu saya. Okay,
Alright.
so for those who just join in and tak pernah sign lagi attendance, okay, please do so by sign the attendance. Okay, that I provided in the chat box here. Okay, so kita sekarang ni kita masuk AVR status register. Since kamu tak ada apa-apa soalan sebelum ni, so kita masuk yang ni lah. Okay, so this status register, okay, like other microprocessor, the AVR has a flag register to indicate arithmetic conditions such as a carry bit. Okay, so this status register is used to indicate the condition lah. Apakah condition yang berlaku selepas kamu buat a few instruction. Okay, so the flag register in the AVR is called a status register, and inside of this status register there are the 8-bit register. Okay, the size is a 8-bit and it contain of this flag here C, Z, N, V, S and H, and then ada lagi I and T. Okay, so this one here we call it as a conditional flag. Okay, to indicate some condition that result after instruction is executed. Okay, so this is your status register. Kalau kamu tengok tadi, the status register is at the end of your IO. Kamu ada I flag, T flag, H flag, S flag, V, and Z, and C. So each of these flag akan menunjukkan dia punya what we call here the status or condition flag lah. Okay, let's look at the flags here. Okay, for the C flag, okay, so the C flag is actually the carry flag. Okay, so this flag is set, okay, akan jadi 1 whenever there is a carry out from bit 7 in which after an 8-bit addition or subtraction. Okay, so C flag akan jadi 1 bila kamu ada carry after you did the addition and subtraction. Contohlah kalau kamu ada nombor, okay, you're going to add with this number here. Okay, so D is bit 7, kita panggil D is bit 7 and bit 0 and D is bit 7. Okay, if you add this number here, two numbers here, so what happen, dia akan kamu dapat 0, 0, 0, 1, 0, 0, 0. 1 plus 1 you get 1 and kamu ada carry kat situ. Okay, so what happen when you have carry? C automatic jadi 1. If you don't have carry from bit 7 ke bit 8, so what happen here? The C akan jadi. Okay, so that is for the carry flag. Okay, while the 0 flag, okay, the flag reflect the result of arithmetic or logic operation. Okay, if the hasil is 0, then Z sama dengan 1. If the result is not 0, then Z sama dengan 1. Okay, so kamu do this addition here. And then you get this result. Okay, since this result here, kamu tengok this is you have still have value. Okay, kamu masih ada lagi 08 value. Okay, you still have the value inside here. So what happens? Z sama dengan 0. If you contohlah kamu buat penambahan and then the hasil of penambahan is 0, 0, 0, 0, 0, 0, 0, 0. So what happens? Z akan jadi 1. So this is for the 0 flag. Okay, meanwhile, for the N flag, which is the negative flag, binary representation of the signed number use bit 7, okay, bit 7 here as the signed bit. Okay, the flag reflect the result of arithmetic operation. If the bit 7 is 0, then N sama dengan 0, which is the CPU know that it is a positive number. But if the bit 7 is 1, then N sama dengan 1, which is result in negative number. Okay, so N kita akan tengok dekat bit nombor 7 kat sini. After you do the hasil penambahan or penolakan or any ALU instruction and the value here is 0, so apa yang berlaku? N automatic jadi 0. If bit 7 ni sama dengan 1, so N sama dengan 1. So the CPU know, okay, this is a negative number and this is a positive number. Okay, so that is for the N flags lah. And then for the V flag, the overflow flag, okay, the flag is set whenever the result of signed number operation is too large, causing the high order bit to overflow in the signed bit. Okay, contohlah kamu buat penambahan 2 sign bit. Okay, you know that the sign bit is bit 7 used to, okay, contoh macam ni ya. Okay, you know that, okay, sorry. Okay, so you know that both of this number is a signed number. Okay, nombor negatif. Okay, macam mana kita tahu dia nombor negatif? Sebab kita tengok kat bit 7 ni. Both have 1. Okay, so the CPU know that this belong to the signed number. So what happen if you tambah this number here? Bila kamu tambah these two number, kamu akan dapat 1. Okey, 1 tambah 1, kamu akan dapat 0. 0 ni kamu akan masuk ke carry pada bit 7, which is your sign number. Okay, so what happen is automatic V sama dengan 1. Okay, so overflow akan jadi 1 because the operation here, the hasil penambahan is too large and causing the high order bit to overflow in the sign bit. Okay, di mana bit 6 tadi, bila kamu tambah 1 plus 1, you get the what we call here the carry. So what happen here is dia akan dapat 1 ke atas ni. So now the CPU know that okay, you have an overflow. Okay, so that's why the V sama dengan 1. Okay, meanwhile for the S flag, okay, the S flag is the result of exclusive OR ring and V flag. Okay, so dia akan buat exclusive OR. Okay, S sama dengan V exclusive OR dengan N. Okay, so kena ingat baliklah truth table of exclusive OR. Bila 0, 0, 0, 1, 1, 0, 1, 1, dia akan jadi 0, 1, 1, 0. Okay, so this S here depending on the value of V dengan N. Okay, and last but not least, the half carry flags. Okay, if there is a carry from D3 to D4 during add or subtraction operation, this bit is set, otherwise is clear. Okay, yang ni dia akan tengok dekat bit 3 dengan bit 4. Okay, so this is bit 3 and this bit 4. Bila kamu buat penambahan ini, 1 tambahan 0, tak ada carry from bit 3 ke bit 4. So, H sama dengan 0. Let's say lah kamu buat penambahan 1 tambah 1 and then you produce a 0 and ada carry ke sini daripada bit 3 ke bit 4. So, automatically H sama dengan 1. Okay, so we will look at a few examples regarding this status register in the next few slides. Okay, for the first example. Okay, show the status of the Z flag during the execution of the following program. Sorry. Okay, so kita tengok the first line here. Okay, mula-mula load IR20 with 4. So what happened? So R20 sama dengan 4. So this is the first line. And then decrement. Okay, so after you do this LDI R24, adakah status register kamu berubah? Is it your status register affected? Okay, kita boleh tengok pada kita punya ini. Okay, instruction set summary. Okay, LDI. Mana kita punya LDI? LDI. Okay, so you see here, this LDI, kalau kamu tengok dekat belah sini, okay, so this, the second last here is for flags. Okay, kalau kamu tengok LDI, none flag are affected. Okay, status register kamu tidak akan affected. Okay, every time you do the data transfer, data movement, okay, kalau kamu tengok kat sini data movement, okay, none of the status register will be affected. But, okay, if you're going to use the arithmetic logic instruction, okay, so this is the flag that akan berubah according to this instruction here. Okay, so kena refer kat sini lah flag mana yang berubah according to the instruction. So the first line here, status register tak berubah. Okay, and then decrement R20. So what happened when you decrement R20? So now R20 sama dengan 3. What about your Z flag? Z flag berubah ke tak? Okay, what is the value of Z flag? Since here dalam R20 masih lagi ada value. So that's why, okay, if you see here, okay, the Z flag masih lagi kosong. Sebab R20 masih lagi ada value. Okay, you decrement again. Decrement R20. So now R20 have 2. So what happened to Z flag? Since R20 masih lagi ada value, which is nombor 2. So Z flag akan jadi kosong lagi. And then you decrement 1 again. Okay, one more time. So sekarang ni R20 sama dengan 1. So what happened to the Z flag? Masih lagi kosong. Sebab masih lagi ada value dalam R20. And then when you decrement one more time, so what happened? R20 sekarang ni dah jadi kosong. Okay, bila R20 jadi kosong, automatically the Z flag will set, akan jadi high. Okay, sebabnya kenapa? Sebab R20 kamu dah tak ada value dalam tu. Okay, so this is how the Z flag works lah. Okay, bila value dalam hasil penambahan penolakan tersebut adalah kosong, so automatic Z akan jadi 1. If not, if have values, then Z akan jadi kosong. Okay, another example. Okay, show the status of the CH and Z flags after the addition of the following instruction. Okay, mula-mula LDI R1638, LDI R17 2F. So you know that. Okay, so 38 R16 akan ada 38, R17 akan ada 2F. Okay, so my advice is every time you're going to determine the status register, okay, I advise you to convert from hexadecimal to binary number. Okay, senang kita nak check kita punya status register. Okay, so 38 2F tukar dulu kepada hexadecimal by using the 8421 method lah. Okay, 8421 38. Okay, mula-mula kita tukar 3 dulu. 0011. What about 8? 8 is 8000. 2F 0010. What if F is 15? 15 is 8 tambah 4, 12 tambah 2, 14 tambah 1, 15. So this is the binary representation of 38 dengan 2F. Okay, next. Dia nak buat apa? Add R16, R17. So kita tambah je lah. Okay, kita tambah this number here. 0 tambah 1, you get 1. 0 tambah 1, 1. 1 tambah 1, 0. And then you have a carry there. 1 tambah 1, 0. Ada carry lagi kat sini. 1 tambah 1 tambah 1, which is 1, 1. So ada carry kat sini. 1 plus 0 is 1 and 0. So the value here, okay, the last value kalau kamu tukar balik, kamu akan dapat 6, 7. Okay, the persoalan is kita nak cari C, H dengan Z flag. Okay, paling senang. Mula-mula kita cari Z dulu. What is the value of your Z flag? Since hasil dia, okay, the result after you do the addition masih ada value which is 67, so automatically Z sama dengan kosong lah. Okay, what about your C flag? Ada tak any carry from bit? Okay, so this is your bit 7 ya. Kat sini bit 7 to bit 8. Tak ada carry kat sini. So C sama dengan kosong. And then what about the H flag? So H flag kita akan tengok daripada bit 3 ke bit 4. So okay, since after penambahan bit 3, you got a carry there. So what happen? H sama dengan 1. Okay. Okay, so this is jawapan lah. C sama dengan kosong. H sama dengan 1. Z sama dengan kosong. Any question? Ada soalan tak? Okay, if no question, then we go to another example. Kita ada berapa lagi example? Okay, ada 2 lagi example kat sini. Okay, show the status of the C, H and Z flag after the addition of 9C64 in the following instruction. Okay, so this is the instruction load I, R20, 9C, load I, 2164, ADD, R20, R21. So now you're going to determine what is the C, H and Z flag. So what are you going to do? So R20 sama dengan 9C. R21 sama dengan 64. So, kita tukar dulu kepada binary number. Okay, 9C is 8 tambah 1. Okay, dapat 9. C, what is C? A, B, C, 12, which is 8, 4, 0, 0. Okay, 6, 4. What is 6, 4? 4 tambah 2, 6. Ia jadi 0. 4 lah. Yang lain kamu letak 0. And then you do the penambahan kat situ. Okay, so 0 tambah 0 is 0. 0, 1 tambah 1 is 0. Then you get 0. Okay, 1 plus 1 you get 0. 1 tambah 1 is 1, 0. So ada carry. 1 tambah 0 tambah 1 is 0. 1 tambah 1 tambah 0 is 0. And you have a carry. Okay, now we're going to determine the status register. What is Z flag? Okay, since the value here is 0, 0. Okay, Z automatic jadi 1 lah. Okay, what about C flag? Okay, so this is a bit 7. You see, you have a carry from bit 7 to bit 8. So, automatic 6 sama dengan 1. And what about the H flag? So, H flag kita akan tengok daripada bit 3 ke bit 4. So, since this is a carry here from bit 3 to bit 4. So, what happens? H also got 1. Okay, and the last one here is, okay, show the status of the C, H, and Z flag after the addition of the following instruction. Okay, again, kamu ada R20 sama dengan 88, R21 sama dengan 93, and you're going to find out what are the H, C, and Z flag after you execute the last line here, ADD R20. R21. Okay, so again, kita tukar dulu kita punya hexadecimal number ni kepada binary representation. 88 is 1000, 1000. 93 is 1001. 8 tambah 1 sama dengan 9. What about this one? 3 is 2 tambah 1 and the rest we put 0 lah. Okay, so kamu tambah 01 is 1. 01 is 1. 011. 0 tambah 0 is 0. 1 tambah 0 is 1. 0 tambah 1 is 1. 0 is 0. 0 is 0. 1 tambah 1 is 0. And then you have a carry there. Okay. So what is the final answer? The final answer will be 1, 8, 10, 11. 11, what is 11? A, B. Okay. 1, B. Okay, now we going to determine what are the H, C, and Z flag kat sini. So, mula-mula kita tentukan Z dulu. Since Z got value, so Z automatic become 0. What about the H flag? H flag kita kena tengok daripada bit 3 ke bit 4. Okay, since after penambahan tak ada apa-apa what we call here, tak ada apa-apa carry from bit 3 ke bit 4, so yang ni akan jadi 0. And what about a C flag? Since this is a bit 7, okay, after you tambah bit 7, 1 plus 1, you got the carry there. So, dia akan dapat 1. So, this is the answer. C sama dengan 1, H kosong, flag sama dengan 0. So, ada soalan. Kita tamat kat sini untuk chapter 2. So, next week kita akan masuk kepada chapter 3. Okay, I think